What I can tell you is that we showed up to a global semiconductor manufacturer and we pitched them our vision of virtual training. Frankly, Adam, they laughed me out of the room. They said, there's no way this would work. This is a toy, video games, like get out of here. And I said, okay, well, you know what? How about you try a prototype? They said, okay. We come back in 6 weeks. They basically went from laughing us out of the room to saying, when can we implement this?
Welcome to the Emergent Podcast, where we interview product leaders from emerging technology companies about their work in the trenches to bring the hardest and most impactful technologies to life. Today's guest is Tim Raftis. Tim is the co-founder and chief product officer at TAP, a startup dedicated to upskilling workers in technical fields using extended reality. Tim is a graduate of Georgetown University, worked at the White House's Office of Science and Technology Policy, was a product manager at Palantir, the product lead at Affinity, and an entrepreneur in residence at 8VC. In this episode, Tim and I discuss virtual reality and augmented reality product building and the unique product challenges this style of work exposes. We discuss how roles and focus areas shift for extended reality, how Tim convinced his first marquee customer to take a chance on TAP. We assess the latest headsets as platforms to build product upon, and we even get into the weeds on what product primitives matter to use in an extended reality training use case. Now a word from our sponsor. This episode is brought to you by Tonic AI. Tonic intelligently transforms your sensitive production data into realistic test data that's safe to use across your lower environments to accelerate your engineering velocity while safeguarding data privacy. We've all experienced the pain and wasted cost of building features with unrealistic data in staging or development environments. Mismatches between prod and test data lead to costly bugs in production, poor user experience, and when it comes to RAG or LLM applications, even incorrect answers. Moreover, as the data scale increases, it becomes difficult for developers to test their features with high fidelity. Tonic's products streamline data synthesis, subsetting, and provisioning to get developers the realistic data they need when and where they need it. Get on-demand access to safe, high-fidelity versions of your structured, semi-structured, or free text data to shorten sprints, catch more bugs, and ship better products faster. Visit tonic.ai/emergent to learn more and receive 15% off in your first year. Tim, so glad to have you. Welcome to the show.
Thanks, Adam. Excited to be here.
So I'd love to start a little bit zoomed out. What are some of the big picture challenges that TAP is designed to solve? And at a high level, how is the company approaching that solution?
Yeah, absolutely. So TAP stands for Training All People. And we are on a mission to help as many people in low-wage, low-skill jobs thrive in the modern economy in manufacturing careers. Now, when a lot of people hear manufacturing, you think manufacturing of old, right? I'm assembling a widget 1,000 times a day with my hands. That's just not the case. We're talking about advanced manufacturing, electric vehicle production, semiconductor production, pharmaceutical production. Technician roles in these environments involve doing preventative maintenance and troubleshooting of extremely advanced automated and robotic systems. And so the impetus for this company, it was really twofold. The first is this gigantic shift we're seeing in our economy of AI that's on everybody's minds right now. And frankly, low skill, unskilled labor is going away. When's the last time you've walked into a grocery store and seen grocery clerks at every single aisle, right? It's just a very visible example of how these jobs are disappearing. And we need to give people a path for dignity and purpose in their career in the modern economy. At the same time, we're undergoing a renaissance of manufacturing in the United States. Just some of those industries I just named, we're making billions and billions of dollars investments in new factories. And one of the biggest risks to making these investments pay off is having the workforce to run them. So we need to create millions of new technicians and production employees to actually run these factories. And so when I was an entrepreneur at residence at ABC, the first approach I thought about in solving this problem was actually creating physical training centers around the US. And what you realize is the equipment you need to buy and the instructors you need to hire in order to create talent at scale, frankly, is never going to pencil into a venture scaled company. And that's when we realized that with the advances in extended reality and spatial computing technology, that you can actually scale this in a way that works using that technology. And so concretely, what TAP provides today is virtual reality training, assessments, and supported online learning to take a novice to productive and able to succeed on the job in these manufacturing environments.
Just for clarification for our guests, for folks who are not doing extended reality, what exactly is extended reality?
That's a great question. There are so many buzz terms and jargon thrown around related to this technology. Simply put, when I say extended reality, what I mean is experiences, digital experiences that are augmenting the reality we see around us right now using a headset, a tablet, a mobile phone, or experiences that are virtual and completely immersive and take me away from the reality I'm in right now. And that would be using a headset, and that's what we call virtual reality. There are experiences that combine them both, and that's what we call extended reality.
So I'm guessing that when you build product for extended reality, there's a bunch of things that are a little bit different, right? Because you're sort of building in three dimensions. You're building in the dimension of reality and additionally the dimension of not actually reality, right? What are some of the unique product challenges that you guys have experienced as you've evolved a product in this extended reality space?
Yeah, I mean, as you know, building great product is never easy, but building great product in 3D world is like turning the difficulty on the hardest setting it can go. There's just so much more you have to deal with. To take a step back, what are some things that don't change? That is that, there are some universal tenets of great product thinking that are always going to translate. You absolutely have to do deep customer discovery to understand their pain points and user needs. You're not just listening to what your users tell you they want. You're really observing them, understanding their workflows, identifying pain points, and as a technologist, thinking about how you can solve those problems better today than you could ever do in the past. You're obviously going to have to ruthlessly prioritize, clearly define scope. We need to use data to make sure the features that we ship are actually effective. All that stuff does not change. However, some of the things that do change or some of the things that are unique about the 3D space, I'll kind of highlight in a few different buckets. The first is the use of senses. So coming from an enterprise, web, and mobile background, the primary sense we're activating with our users is sight, visual sight. But when you move into a 3D immersive experience, there are two more senses that you have available to you as a product designer. And in fact, it's not just an optional thing. You absolutely need to use these senses well to develop good experiences. And so that's not just sight, but also touch and also hearing. So to give an example of how you need to consider these senses when you're building products in this medium, I'll kind of walk you through a framework I use when we're designing some of our trainings. So many times we're training somebody how to do a preventative maintenance task. So let's say we're walking somebody through how to change a circuit breaker on an electrical panel. The framework I like to think about for each individual step in that procedure is a trigger, an action, and a response. So first, we need to trigger the user to actually do something. They need to then do it. And then the product needs to give them a response on whether or not they did it right or wrong. So in that trigger, let's think about it. If the first step is to open the door of the electrical panel, I probably need to give some visual cue on that electrical panel to draw the user's attention there. If they stare at it and they don't actually do anything, maybe I need to surface a UI that tells them the 3D controls on how to go open that door. Well, let's think about where I place that UI panel. It's not just about information hierarchy or the font size, panel size. It's actually where am I putting that relative to the user's point of view? And if they move around, walk around, how does that UI panel change? Should it billboard with where they're looking at? Should it actually follow them? And so there's a lot of visual complexity you need to think about. Now, when we think about the sense of hearing, is there an auditory cue that tells the user what to do? In our case, we actually have a virtual assistant, a virtual instructor, essentially, that's telling you what to do and why to do it. And then haptics, touch, maybe in this case, we don't need that. But in other cases, maybe there's a vibration or something that would indicate something's going wrong in a machine. We actually need to think about the haptics and the intensity of those haptics in the controller. Then you get to the action, right? Actually opening the door. Is the haptic extremely intense when you first grab the door, or maybe medium, or when you're opening it, is it dull? What does that sound make when you open the door? Then for the response, is there a visual cue that tells you if you did it correctly, an auditory cue, a haptic cue, so on and so forth? So, these sound like trivial things, and, you could go down the rabbit hole, and pretty much my team does. But the difference in thinking these things through is the difference between a user walking away and saying, oh, this was a cool demo. This felt like a toy. And then a user walking away and saying, oh my gosh, that was real. I know how to do this. I have the confidence I can do this job.
Yeah, it must be really interesting to try to bring together all of those senses. So someone might need to be able to sort of like reach into the experience and then touch something and say, oh, I feel there's bumps here and aren't supposed to be bumps here. Like you've got to get down to that level of detail.
That level of detail. All of a sudden, product almost becomes analogous to a movie director. It's actually been really, really fun, but not easy for sure.
It's also fascinating that you guys discovered that people would still prefer to have a personoid instructor inside the experience. Is that right? So instead of just a ton of cues, there's actually a human inside the loop with you, or an artificial human?
Yeah, absolutely. I think humanizing that experience and presenting the user in an environment where they feel comfortable and they recognize some similarities to reality helps them focus on the learning as opposed to the technology, which obviously is super important.
When you think about this extended reality environment, what are some of the use cases that are great fits here? And then at a high level, like what are some of the use cases that are just not a good fit for this sort of training environment?
Yeah, so this gets me super fired up. Maybe I'll say something controversial here, but I think most builders of 3D products are not using the medium correctly, especially in training use cases. And what I mean by that is just because I could build a great simulation on how to train somebody to use a tape measure doesn't mean I should. Now, why is that? Well, that's because you can go buy a tape measure and watch a YouTube video and figure out how to use the thing.
Seems simple enough.
Yeah, it's not rocket science for sure. There's some criteria we think about when we make the decision to invest in building an XR experience for training. One criteria might be, are you training on a piece of equipment that is either extremely dangerous to use? Is it really expensive to get access to? Maybe it's not expensive, but it's just hard to get access to. That's one criteria. If it fits those gates, probably a good use case for XR. Another thing to consider is concepts that are extremely difficult to visualize in reality. So if I want to, going back to the electrical example, if I want to show how various electrical wires and circuits are activated to make a machine work, I can't visualize that in reality. But with VR, I can actually see the electricity. We can create a visual effect to demonstrate how these technologies actually work, which gives our trainees a better understanding of how and why things work, as opposed to just this happens.
You're actually saying, I don't just want to create a perfect audio, visual, physical replica. I also want to create experiences that people cannot have. Even if you could have 100 rockets ready to work on at a moment's notice with the flick of your hands. This is still better because you can get a layer deeper to visualize things and have them experience things that are not actually touchable or feelable, right? You can't sense them yourself.
That's it. That's exactly right. Things like plasma, which is basically when gas ionizes at extremely high temperatures, it creates this plasma, which is actually the fifth state of matter. You can talk to your science teacher about that. That is extremely difficult to view in real life. And those plasmas are actually getting created inside machines in the semiconductor industry. But if you go poll the millions of workers in that industry, probably most would tell you they have no idea what a plasma looks like. But with TAP, you can actually visualize these types of concepts.
And I guess that would also give you some additional respect too for, hey, this chamber over here has something extremely hot in it that could destroy the whole laboratory if I don't, open and close this particular valve properly. Is that right?
That's exactly right. And, kind of what you mentioned is a combination of the criteria we just talked about, just safety and then visualizing concepts that maybe you couldn't without VR. That's a slam dunk, right? That those are the concepts that really drive a lot of value in the training space.
Can I ask, what was one of the first use cases that you guys did focus on? You mentioned some things around electrical panels and plasma. Like, which one did you take first, end to end to really get through it?
Yeah, so I'll tell you a story. I cannot share the customer name, unfortunately, due to NDAs. But what I can tell you is that we showed up to a global semiconductor manufacturer and we pitched them our vision of virtual training and helping them generate the workforce they need given the billions of dollars of investments they've made. And frankly, Adam, they laughed me out of the room. They said, "This is crazy, Tim. Like, there's no way this would work. This is a toy, video games, like, get out of here." And I said, "Okay, well, you know what? How about you try a demo? How about you try a prototype?" They said, "Okay, but you can't build it." So we said, challenge accepted. We come back in 6 weeks. And in the semiconductor industry, vacuum technology is really critical. Put simply, every microchip that's produced, most of the processes are done in a vacuum chamber where there are less particles in that chamber than there are in space. And being able to check these chambers for leaks are super essential. Well, the cost of one of these chambers or one of these machines that has the chamber are millions of dollars. The leak checking devices you use to check for leaks, maybe $15,000, and good luck finding a working one on the factory floor. And so we built a very simple tutorial on how to conduct a leak check on one of these vacuum chambers. And they basically went from laughing us out of the room to saying, when can we implement this? And we are now mandated training for every single one of their production employees. So good example of a use case where the equipment, super expensive, the technology and the process, super critical to the employer. And then another piece, which I'll touch on, which is that our education system today, or community and technical college system today, doesn't have a lot of content around this subject.
When you think about these challenges, what are some of the, like, how, when you try to move all of these pieces at the same time and you think of a normal product development cycle, like if you were to give advice to a new product manager going into this space, how would you tell them to think differently about setting up their product development process? Like, for example, well, you just described a fantastic example of how you assess the value of the product. And you did it with this extreme knowledge of the business. But then there were all those other aspects you mentioned about the technical pieces and the haptic pieces and the audio. Like, do you have a process that you kind of work through, or a set of heuristics? Like, how do you think about that?
So I'll actually start with the team and the people, because I think that's essential. A typical build team, scrum team, whatever you want to call it, has a few key roles. So first, you're going to have the product owner, likely, and I would always recommend, have a dedicated UX, UI designer as well, product designer. That's no different than what we're used to. A role that's a little bit unique in 3D world is something called a technical artist. And this is somebody who focuses on the 3D modeling of objects in the space, as well as the visual effects. So if I want to simulate gas traveling through a gas line, there's probably some visual particle effect that I should animate. That's a very specialized and particular skill set. Frankly, they're kind of unicorns. So if anybody knows a great technical artist, we're always looking to hire those. And then, of course, you have 3D developers as well. So that's kind of the core team. As far as the process, as I mentioned, you're going to start with customer discovery on whatever feature or use case or area you're looking to explore, and then narrowing that into a core problem or set of problems you want to solve with whatever you're going to build. The next piece, which is used by a lot of product teams, but I think really important in this space, is storyboarding. And that's because it's essential that you consider not just the experience in the headset, but actually what's happening before and after you put on the headset or take off the headset. Most of the folks that you're going to encounter in the training space in particular, this isn't just the first experience with your app. This is the first spatial computing experience they've ever had. So how do you make that really seamless and do your best to teach them the controls? So once you have that kind of storyboard of what the overall user journey is going to look like for whatever solution you're building, then you're going to go into the prototyping stage, or at least we do. Figma is amazing. We like to use that for UI design. There's certain types of animations or more dynamic things you can do with it, but it does have its limits. And so this is where it's really essential that you start to identify what are the most critical parts of this 3D experience that you're building, and then what are the best ways to prototype and de-risk that experience or that interaction or that feature is going to work how you would like. Some tools you can use are actually video. So you might be able to record yourself doing something, picking something up in reality, and then actually annotating that video with augments, UIs, and different cues that you might want to build. But frankly, at some point, these prototyping tools only get you so far. And so you need to develop the conviction to then take that to dev and go build a proof of concept. So again, that's where you really need to focus on what are the highest risk aspects of your solution or the highest value driving parts of your solution. Prototype that first, because frankly, it's likely you're wrong. And so it's really important you test that before you build out the full feature. Once you've de-risked that, build out the full feature, evaluated success, repeat, iterate.
Hearkening back to our days at Palantir, is there an aspect here of the discovery that just has to be hands-on? Like, do you have to be in the factory yourself watching this happen in order to build a great product for it? Or have you found other ways to dial up that knowledge? Because I feel like it's just a standard user interview. Even if you ask the right questions, you might not be able to, have all these other dimensions in your head.
You absolutely have to have subject matter experts who can help you understand the real life process. If you can get access to the factory, even better. That's definitely how we develop today. But in the early days when we couldn't get access to those factories, we did bring on subject matter experts who could really deeply explain procedures, point us to content, videos, things like that. You cannot rely on user interviews alone. You absolutely need to see what's happening.
Is your office just completely filled with foam and things to cut it with? So you could be like, no, it's supposed to look like this. And you shave a little bit of something on it. It's like you guys have a shopping spree at Michael's or something.
We definitely have a very full garage full of fun goodies. The office is mostly just headsets, but yeah, we'll move to the garage when we're ready to get to some parts.
This episode is brought to you by Propel Auth. Startups and corporate innovation teams routinely waste months building core user authentication and authorization flows into their products. Propel Auth has automated all the most important pieces of the user management lifecycle. Instantly set up wait lists, magic links, social login, user impersonation, user management, role-based access control, SAML integrations for enterprise, team management, and much more. With Propel Auth, each of these challenges takes just a few lines of code instead of months of development and integration time. And with thoughtful control over design and skinning, it's easy to keep your product fully on brand. Get a generous free starter pack that scales through 1,000 monthly active users, or mention Emergent25 to receive 25% off for the first 6 months for more mature products. Get back to building your actual product and let Propel Auth handle your user management needs. Visit Propel Auth, that's PROPELAUTH.com to learn more. So thinking about, your goal is obviously to train upskill a ridiculous number of people to support the goals on employment here in the United States. I imagine that in order to do that, you've got to support a wide variety of use cases over time. Like, what does one product primitive look like in a tap reality? In a normal company, it's like, oh, we need an API that does this. We need a button that does that. Like, what's one primitive for you guys, given that one day it's a semiconductor and the next day it's a plasma chamber?
Product primitives and design systems, interaction systems, I think are critical to developing a consistent, high quality product experience. And so there's maybe two aspects of our product that I'll talk about right now. One is our interaction system. So what I mean by that is when you think about all the different types of manufacturing or troubleshooting or maintenance scenarios that you could run into, you can actually deconstruct those into a set of interactions that you can consistently use across different content. So an example might be, how do I turn a valve? How do I open a door? How do I use a multimeter lead on an electrical component? Right. And so what we did is over time, look across all the different content we've built and try and standardize these interactions so that from a technical perspective, they translate across different simulations that we build. So we build all the logic to turn a valve once, and then we're able to implement that in specific simulations. Another core piece of infrastructure that we've built is a state machine or logic engine. And so what I mean by that is we're able as instructional designers or product designers to define a lesson or a goal, a set of tasks and goals that a user needs to do that are related to objects in the simulation, and track what the user is doing, the states of those objects, and determine if they succeeded or not. And then more importantly, when they make mistakes, let them make mistakes, but then give them corrective feedback so that you learn the hard way, the easy way, for lack of a better term, right? If I'm going to leak hazardous gas in a factory facility, I probably would rather do that in a virtual environment than the real environment. And we can actually have users play in that sandbox, make the mistakes, and correct them.
And is there a gamification component to that, or it's like, hey, you've reached toxic levels, like your character needs to respawn, or you just say game over, you get to start again?
Yeah, I mean, it's always a trade-off, right? Between yes, we want to have our users walk away and say, I want to go use Tap again. That was awesome. But at the same time, we don't want to trivialize mistakes that could cost lives in the factory. And so I think it's always a trade-off. To give you an example, though, anytime you complete a task in our simulations, you'll see a little green highlight response on the object that was related to that task. And you hear a nice little green ding, right? It sounds kind of silly. It's fun, but I thought it would be this little thing, actually. And when we implemented it, we had a customer run a training. And I promise you, Adam, I saw a 45-year-old woman doing our training. And every time she heard the ding, she would do a little dance. And she was so happy and excited. And so yeah, those things matter.
That's great. That's great. That's a new level of user experience. So can you thinking about the journey that you guys have been on and all the learning that anyone entering this field would have to do, Can you think of a time when the team's judgment on product wasn't what you expected it to be? And how did you guys discover it? And what'd you do about it?
Yeah, too many times. Frankly, I'm kind of embarrassed to admit, but that's learning. One time in particular um, was when we were developing the core guidance UI. So as I mentioned, we're oftentimes guiding a user through a set of steps and tasks they need to do at a training, and there is a UI panel that helps them keep track of where they are and what they need to do next. And we are always pushing ourselves to think about, what's the 12 out of 10 product experience, not just the 10 out of 10. And so we had this brilliant idea that wouldn't it be great if that instructions UI panel was always in the perfect point of view, no matter where you walked around in the space, no matter where you looked, it was always just where you needed it. And that's one of those things you can kind of storyboard or talk about, and it sounds great, right? Well, in reality, what happened was, and this goes back to determine what the highest risk is in the feature and then prototype it. The reality is, when you implemented that logic to always have it in a specific point of view, you just ran into all kinds of terrible problems, right? It would hit other objects in the space or not be visible because it was conflicting with other objects in the space. It was actually very jarring because there are times in a simulation where you don't want to look at the instructions UI panel. Maybe you're just amazed by this environment and you want to go explore, but instead you have this UI panel in your face, just kind of like yelling at you to do something. So that was one that was relatively easy to see the error of our logic in the prototyping phase. But again, that's why I think it's so important to invest in those proof of concepts before you build out the full feature.
You think to yourself, I'm training them, so there's this list of instructions. And of course, they're going to want to see those instructions. But then what you're really learning is the user, in order to learn how to do something, it's not the instructions, it's the instruction, and then pause, observe and interact with your reality, take in those new dimensions, process it in your brain. And now I'm curious about the next step. So I'm guessing as you are doing this work and are supporting a variety of different VR headsets, obviously a lot of people are buying these for consumer purposes. You guys are using them for these fantastic industrial purposes. How would you say the available ones are for doing real training work? And what are some of the major limitations you guys are experiencing with the off-the-shelf hardware?
Yeah, the hardware is getting really good, and that's very exciting. We use all different types of headsets. I will say that generally we find that the MetaQuest 3 is the best bang for your buck, and the MetaQuest 2 is also phenomenal for the price. And obviously, the Apple Vision Pro is a new device that has a lot of people excited. In terms of the use cases, virtual reality experiences using these headsets, we've arrived. There are technical limitations, but you can develop full enterprise training programs and scale these programs to thousands of trainees today, full stop. When you talk about AR experiences, extended reality experiences, we're getting a lot closer, but some of the limitations include the compute power of the headset and the ability to use image recognition algorithms and technology to anchor UIs to particular objects in a space. I think it's anytime you see an augmented reality demo where you're doing some work on an actual piece of equipment and the UI is just perfectly placed, it's telling you exactly what you need to do. It looks amazing. And we're not quite there in practice yet. It's actually a little bit more buggy, but like I said, the technology has gotten extremely powerful. Some trade-offs though that you have to keep in mind as a product builder is thinking about obviously the device cost, the compute power, and then the fidelity of certain parts of your experience, and then human physiology. So what I mean by that is frame rate is super important in these devices. And if you go below 70 frames per second, really bad things happen. Folks start to get headaches, they can develop nausea. It is not a good experience. And so as you're developing any 3D experience, you really need to ask yourself, what parts of that experience need to be extremely detailed and rendered, realistically, or using some great effect. And then what are the other parts that maybe don't matter as much? And then use sleight of hand and strategy to make sure those components that really need to be high fidelity, back to the electrical example, maybe a circuit board needs to be really high fidelity, but there might be some other machine in the background where you can actually obfuscate the detail of that machine in order for the headset to render effectively.
So you now get to determine the next 3 features that are built on the Meta Quest. Like, what's your top one? What do you want to see happen there to support a wider set of use cases? Is it edge computing detection and stronger chip? Like, what do you think it needs to be?
Yeah, I mean, we could always use more CPU and more memory. So I'll definitely throw that one in there, and hopefully we continue to see this increase. They've made some really great advancements in pass-through, which basically means when I'm wearing this headset, there is a mode where I can see the reality around me using cameras. And so making that fidelity of those cameras higher quality and giving developers access to that camera to be able to augment that reality around them is something I would love to continue to see. And then honestly, the third one, which is not necessarily a technical challenge, it's just better support for enterprise B2B use cases, and specifically mobile device management. When you set up a pilot for one of these large manufacturers and they're buying 10 headsets and running one cohort, everything's pretty seamless, right? It's not a ton of mobile devices to manage for their IT, not a lot of user accounts, et cetera. When you start talking about thousands of devices across the US and even globally, and how their IT manages those devices, that becomes really complex. And I know Meta is taking strides to improve their support with a program called Quest for Business, but I would like to see the velocity increase rapidly, let's say.
Is part of the concern that, one, these are expensive devices, but then two, some proprietary IP is on them, or is it all cloud-based? Like, what's the main concern for the businesses around managing, 1,000 devices?
Yeah, it's really all of the above. It's managing customer data. Depending on how the headsets are used, the data may be more or less sensitive, right? If I understand a certain employee's skill level or performance on a simulation, maybe that doesn't matter that much, but maybe there's some custom content around how to manage a nuclear meltdown and a nuclear reactor in one of these headsets. That's really important not to get out. And then there's the standard minimizing threat vectors for malware or cyber attacks. Those are the two main concerns.
What comes next for TAP, and what are some of the riskiest product value propositions you guys have to test next?
Yeah, so we are very fortunate to be the leaders in training for semiconductor manufacturing, and we're going to continue to grow that business. And we're also looking forward to expanding that reach beyond semiconductor. And so we're focused on industrial companies who are using multi-axis robots. So think about, the robots you see in the Tesla factory that are welding or painting, but you can also see those same types of robots in logistics facilities, in pharmaceutical facilities, food processing facilities. So we need to prove that we can expand our content beyond this initial foothold of microelectronics, which is going great. And then, the other thing that we're thinking about, I won't give it all away, but we have relationships with colleges and educational institutions across the US. We also have relationships with some of the largest industrial employers in the US. So what else can we do to connect the two and support problems along that whole talent development lifecycle, whether it be recruiting, evaluation, upskilling, assessment? There's just so much surface area that we can help our customers with.
Excellent. Sounds really fun. I'm excited to see where it goes and maybe check it out and learn how to do something I don't know how to do at some point. If the audience or potential customers or VCs or others want to get in touch with you, where would you like to be contacted? How can they get a hold of you?
Yeah, they can just reach me. I'm Tim at tap3d.com. I would love to hear from anyone where this mission resonates.
Excellent. Thank you so much, Tim, for joining us, and everyone in the audience for listening.
Thanks, Adam.
We'll see you next time. Thank you so much for listening. Emergent is brought to you by First Principles, where we provide emerging technology product coaching and fractional product leadership to founders with bold visions. If you found this valuable, you can subscribe on Spotify, Apple, or wherever you get your podcasts. Please consider leaving a review or sharing feedback directly with us. You can always find previous episodes, show notes, and more content on www.emergentproduct.com.